Hi, in this video, we're going to learn about the dot product. Now, how do you find the dot product of two vectors? Well, let's start with some two-dimensional examples. Let's say we have u is a1, b1, and v is a2, b2. Then you're going to multiply like components and then find the sum. So, for example, you're going to take the first component of both u and v, that would be a1 times a2. And then you're going to add the multiplication of this second component, so b1 times b2. So u dot v equals a1 times a2 plus b1 times b2. Let's put that into practice with this example. 5, 6, dotted, negative 3, 4. So I'm going to use that formula. And I'm going to start by finding the first component of each of my vectors. So really I have 5 and negative 3. So I'll multiply those. Then I'm going to have to do plus, and I'm going to look at my second two components, 6 and 4. I'm also going to multiply those. Then I'm going to add them at the end. So now I just need to simplify this. 5 times negative 3 is negative 15, and 6 times 4 is 24. When I add those together, I get 9. So the dot product of 5, 6 and negative 3, 4 is 9. What if I need to find the dot product between three-dimensional vectors, though? Well, now I'm going to have u is a1, b1, c1, and v is a2, b2, c2. The really good news is that the same method applies. We're going to multiply like components and then find the sum. So u dot v is a1 times a2 plus b1 times b2 plus c1 times c2. All we've done is added that last part with the c's at the end. So let's say I want to find the dot product of 3, 1, negative 2, and 5, 0, 1. Well, I'm going to use that formula we just talked about. And the first component for each vector is 3 and 5. So I'll multiply those. The second components are 1 and 0. So I'll multiply those. And my last component is negative 2 and 1. So I'll multiply those. Then I'm going to add up all of those products. When I go to simplify this, 3 times 5 is 15. 1 times 0 is 0, and negative 2 times 1 is negative 2. So I have 15 plus 0 minus 2, which is 13. And that's the dot product of those two vectors. And that is how you find the dot product, whether it's a two-dimensional set of vectors or the vectors are 3D.